This sample problem is on contact forces and its relation to Newton's laws of motion. A 7 kilogram block and a 2 kilogram block are in contact with each other on a horizontal frictionless surface. The 7 kilogram block is pushed by a 36 Newton force as shown below. First question, what is the acceleration of the two boxes? So once again, in situations where you have more than one object and the question is asking for acceleration, you could just consider the object as one, so you are going to use the system approach. So in this case, we solve for the acceleration using Newton's second law of motion. F net is equal to ma, and when we say F net, it would only be the external force or the force that causes the system to move. So in this case, the only force that's making the system move is this applied force of 36 newtons. So that would be our applied force. And that is equal to the total mass of the system, since we are now talking about these two objects. So we will have the 7 kilogram object, or we call this, if this is M1 and that is M2. So we have M1 plus M2 multiplied by the acceleration of the system. So we substitute our values. The applied force is 36 newtons. Again, this is the only force that's making the system move. M1 is 7 kilogram plus M2, which is 2 kilogram, multiplied by the acceleration. And you plug these values in your calculator, you'll get acceleration is equal to 4 meters per second square. Now for the second question, what is the magnitude of the contact force between the two boxes? Now, since these two objects, M1 and M2, are actually in contact with each other, then we actually have the so-called contact force. So what happens is that, although the 36 Newton force is only directly acting on the 7 kilogram box, but then both of them would actually be moving forward, and that is because the 2 kilogram box is actually being pushed by the 7 kilogram box. And according to Newton's third law, the 2 kilogram box would also exert a force on the 7 kilogram box, and this force that exists between the two objects is what we call a contact force. So if we're going to draw that, we will have this force here. This is a contact force, or the force of the 7 kilogram block on the 2 kilogram block. And on the other hand, we also have another contact force in the opposite direction, which would also be a contact force, and this is the contact force exerted by the 2 kilogram block on the 7 kilogram block. Now these forces are equal in magnitude, but they're pointing on different directions, and they're also acting on different objects. So for example, this FC right here is acting on the 2 kilogram box, and this other contact force right here is acting on the 7 kilogram box. So if we're going to draw the free body diagram of the 7 kilogram box, it is going to look like this. So we'll have the dot right here, the dot which represents the 7 kilogram box. So there is an applied force of 36 newtons that points to the right, so we have our applied force. And we have the contact force that is due to the fact that the 2 kilogram box will also exert a force on the 7 kilogram box. So this is the free body diagram of the 7 kilogram box. On the other hand, for the 2 kilogram box, it is going to look like this. We have the 2 kilogram box, and the only force that is acting on it is in fact the contact force, or the force of the 7 kilogram box on the 2 kilogram box. So we would only have this arrow that would represent the contact force. This is the free body diagram of the 2 kilogram box. So this is the 2 kilogram box, and on the other hand, the one on the right is our 7 kilogram box. So there are two ways by which we could solve for the contact force that is being asked on the second question. We could either use the 7 kilogram box or the 2 kilogram box. So let's try this one. Solving for the contact force using M1. So we'll have F net is equal to ma, and once again, for M1 or the 7 kilogram box, the net force would be composed of your applied force pointing to the right and your contact force that is pointing to the left. So we will have our F net then becomes applied force positive minus the contact force negative is equal to MA. And we substitute the values now. Our F net, our applied force is 36 newtons minus the contact force, which is what we need to solve for, is equal to the mass that we're looking into is the 7 kilogram mass. So we will have 7 there multiplied by the acceleration, which is the acceleration of the system that we have solved earlier, and that is 4 meters per second. And now we plug these values in your calculator. We'll have the contact force is equal to 8 newtons. All right. Now we solve for contact force using M2, and we expect that this contact force would be also 8 newtons. Let's try that out. So let me just write solving for the contact force using mass 2. All right. So let's start with F net is equal to MA, and if we're going to look at mass 2, this is the free body diagram of mass 2 or the 2 kilogram block, and the only force acting on it is the contact force. So in fact, our F net here, as we use the 2 kilogram box, would just be the contact force. So that's our F net, and that is equal to MA. So since we're solving for contact force, we will have Fc multiplied by the mass of block 2, which is 2 kilograms, and the acceleration is 4 meters per second squared. So the contact force is equal to 8 newtons. So either way, these solutions are actually acceptable, but it is very important to note that if we use M1 or M2, the contact force would actually be the same. So as a summary, as we solve for the acceleration of the two boxes, we are going to use the system approach, wherein we would only look into the external force that is acting on the system or making the system move. And don't forget that the mass that we're going to use in F net is equal to MA is the sum of the masses in our system. On the other hand, if we are going to solve for the contact forces between the two objects, so we will have to look into the free body diagram on the object and take note that since the two objects are actually in contact with each other, then these two objects will exert a force on each other. For example, mass 1 will exert a force on mass 2, and mass 2 would also exert a force on mass 1. And this force that exists between two objects that are in contact with each other is what we call a contact force. And in solving for contact forces, it is very important that we are going to look at each mass individually.